if I were going to ask you, what's the probability that you lose your job or your car breaks down? Now, you might be tempted to tell me probability you lose your job 10%, probability your car breaks down 30%. You might be tempted to tell me that it's just 30%, a 30% chance. But what you see in the general addition rule in the bottom of page 154, that you need to subtract out the and, the probability of A and B. Why? Well, because it gets double counted. If you see this 2% overlap, a 10% chance you lose your job, a 20% chance your car breaks down, but there's a 2% overlap. So you can see that it actually gets double counted. So if you were going to say the probability you lose your job or your car breaks down is the probability of this space. In this space is 8 plus 2 plus 18, which is 28. Now, the general addition rule says it's the probability of A plus the probability of B minus the probability of A union B. Or 10 plus 20 minus 2 equals 28. But this doesn't make any sense unless you see the overlap, which is represented in the Venn diagram. Okay? So, now, lots of things you can do on these Venn diagrams. Let me redraw my circles because they're getting messy. Now, I'll just go to A, B, A and B. Okay? Now, we can do a lot of things. If here's the probability of A, whatever that would be, let's assign a value of 30 to the probability of A, which I have shaded here. The probability of A complement is everything outside of A, which I will represent in red. Okay? And A complement would be, you're right, 100 minus 30, or 70. Okay? And again, the probability of B is this circle. Everything outside of B would be outside of B. Now, this is a Venn diagram. I think they're very helpful in understanding statistics and probability, okay, in the general addition rule. Now, in this section, we have a little bit of practice on this homework, and that's going to be 4.1, 4.2, 4.6, and 4.7. Okay? These 4 problems. Conditional probability. This can be a bit intimidating, but very important. Very important. This says, what's the probability something happened given we had some information already? Now, not to spark a political debate, but the 9/11 towers, if that was a random event, the attack on the 9/11 towers, if that was a random event, what's the chance of that happening? A catastrophic event such as this? Very low. Very, very low. That both towers would be hit, both towers would fall. Very, very low. But if you watch some of the processionals in the court hearings, if you read some of the literature that's published around those events, you'll know that there had been some prior warnings given information that a terrorist cell might be wanting to attack and attack with commercial airliners. Now, that information had been relayed to the administration. Okay? Given that information, what's the probability that there was a terrorist attack on the World Trade Center towers? That changes your probability. Yeah? It changes your perspective on the event. You think it's much more likely, if we have this information, that an event such as that could happen. Okay? That's the best example I can have of conditional probability. If you say, what's the probability of a natural disaster happening? Let's say an earthquake. What's the probability of an earthquake? Well, I come from Ohio, and we don't have that many earthquakes in Ohio. So I would have to say the probability of an earthquake is very, very low. But what if I gave you, what's the probability of an earthquake given that you live in California? Well, then that increases the probability of it happening. See, that given that information increases the chance of something happening. Okay, that's called conditional probability. And it's read like this. The probability of A given B. That's how it's read. Probability of A with the line given B. That's how it's read. Excuse me. Now, this in a formula, just to make sure I'm clear. Probability A and B over the probability of B. This is saying the same thing. The probability of A given B. Okay? If A and B don't make any sense, the probability of earthquake given California. Okay? A given B. Probability of earthquake given California. Probability of terrorist attack given information from the intelligence agency. Okay? Different events. Conditional probability. Now, how do we apply this? Well, going back to our problem, probability of purchase, actually purchased, given that they plan to purchase. Now, that's a lot different. The probability of actually purchasing a television we looked at was 250 out of 700. The probability that they actually purchased, given they were going to purchase in the first place, that increases our probability. Now, how do we look at that? The probability A and B over the probability of B. Now, if you look on page 158, you can follow right along, but the probability of they purchased and they plan to purchase was 200 out of 1,000. Divided by the probability they actually plan to purchase, and there were 250 out of 1,000 that plan to purchase. You should know that you can invert these and cross out your thousands. If you have a fraction on the in the bottom, you can invert it and cross it out, but it ends up looking like 200 out of 250. Okay, is your probability that they purchase, given that they plan to purchase, or this is 80%. And I'll put that here, 80%. Okay, conditional probability. Now, you can follow on page 149 about DBRs. I would encourage you to practice through example 4.6. Okay, you will have a test question about conditional probability. So you need to make sure you understand it.